Fossil fuels. Coal, natural gas, and petroleum are the three main types of fossil fuels. These fuels are formed from the remains of dead plants and animals over millions of years under high pressure and temperature. Methane as main constituent of natural gas. Natural gas consists mostly of methane, CH, which is a simple hydrocarbon. Methane is highly flammable and is used as a fuel for heating and electricity generation. Hydrocarbons. Hydrocarbons are compounds made up of hydrogen and carbon atoms only. They are the basis of many fuels and can vary in size, affecting their properties and uses. Petroleum as a mixture of hydrocarbons. Petroleum, also called crude oil, is a complex mixture of hydrocarbons of different sizes and structures. It can be separated into useful components by refining. Fractional distillation of petroleum. Petroleum is separated into fractions by fractional distillation in a fractionating column. The crude oil is heated, and its components are separated based on their boiling points. Each fraction has different uses depending on its properties.
Fractional distillation is a special type of distillation designed to separate a mixture of two or more liquids which tend to have different boiling points. During the fractional distillation of crude oil, heated crude oil enters a tall fractionating column, which is hot at the bottom and gets cooler towards the top. Vapors from the oil rise through the column. Vapors condense when they become cool enough. Liquids are let out of the column at different heights.
Properties of fractions. Bottom fractions, heavier molecules. Longer chain length of hydrocarbons. Less volatile, do not evaporate easily. Higher boiling points, require more heat to boil. More viscous, thicker, flow more slowly. Top fractions, lighter molecules. Shorter chain length of hydrocarbons. More volatile, evaporate easily. Lower boiling points, boil at lower temperatures. Less viscous, flow more easily.
So first of all, sulfur is removed from the crude oil, and then it's heated as it goes into the fractionating column, which is used to split the crude oil into its constituent components, mostly hydrocarbons. At the bottom is the residue, where there are chains with 25 or more carbons, and that's where the highest temperature is. And using the different boiling points, you'll split apart the various components of the crude oil into gas oil, kerosene, gasoline, and finally refinery gas. Now you have to know about the thermal gradient as well. So it's hot at the bottom and cooler at the top. So what are the uses for these various fractions of crude oil? Well, let's start with the lightest fraction that comes out of the top. That's used for cooking gas and feedstock. Feedstock is a reactant used for other chemical processes. Slightly heavier is the gasoline and naphtha with 5 to 10 carbons in a chain, used for petrol. Jet fuel and helicopter fuel is the next fraction, which is kerosene. It's also used for domestic heating. I've also put the boiling points there as well.
Uses of petroleum fractions. Refinery gas fraction, used for heating and cooking, in homes and industries. Gasoline petrol fraction, used as fuel in cars. Naphtha fraction, used as a chemical feedstock in making plastics, chemicals, and other materials. Kerosene paraffin fraction, used as jet fuel and for domestic heating. Diesel oil gas oil fraction, used as fuel in diesel engines, e.g., trucks, buses. Fuel oil fraction, used in ships and for home heating. Lubricating oil fraction, used in lubricants, waxes, and polishes. Bitumen fraction, used for making roads and roofing materials.
Simplify your chemistry journey. Subscribe now for easy-to-follow tutorials.